Hi everyone, welcome to fourth grade enhanced math week 4 travel and other speed problem solution video. This time it will cover 16 problems that you guys did this week and the solutions to all of them. So let's start right off with problem 1. A car travels at a constant speed, which means it travels at the same speed for all when it travels, of 60 kilometers an hour for 3 hours. How far does it travel? So first let's break it down. 60 kilometers an hour. So 60 kilometers is the distance that it travels, distance in 1 hour. And we also know that distance is equals to speed times time. And if we know that in 1 hour it travels 60 kilometers, then all we have to do is times 60 by 3 since she travels 3 hours constantly, which means that the total distance is 180 kilometers. Problem 2. Alice walks at 4 kilometers an hour while Bob walks at 6 kilometers an hour. If they both start at the same point in time, how much farther will Bob have walked than Alice after 2 hours? So let's calculate how much they walk. So let's say that they start at this point right here in blue. And then we have to see how much they walk after 2 hours. So Alice, let's do Alice in this color. Let's say that she walks this much. And we know that Alice walks slower than Bob, right? Like because 4 is smaller than 6. So let's do Bob right here. Bob. And then he does like this, right? And then we know that in 2 hours, Alice must have done 4 because 4 is distance, right? Times time, 2 hours, equals to 8 kilometers in 2 hours. So this is 8 kilometers. And then we can do the same for Bob. Bob is just 6 kilometers times 2 hours, 12 kilometers in the same time. Which means that Bob will have walked 4 kilometers further than Alice, since Alice has walked only 8 kilometers, but Bob has walked 12 kilometers. Problem 3. A robot can wrap 24 presents in 2 hours. If it works at the same rate, how many presents can it wrap in 45 minutes? So step 1, we have to find the rate per hour, right? So it says that it can wrap 24 hours in 24 presents in 2 hours, which means that if we divide 24 hours by 2 hours, 24 presents divided by 2 hours, this gives us 12 presents an hour. And then we have to convert 45 minutes to an hour, right? Because we have to see how well 12 presents an hour fits into 45 minutes. So 45 minutes, isn't that just 3/4 an hour? Which means that 12 presents an hour, if we took 3/4 of that, then 3/4 of 12 would just be 9. So therefore, in 45 minutes, which is 3/4 of an hour, then 9 presents the robot would make in 45 minutes, since 9 is 3/4 of 12. Problem 4. Lily and Coco are folding paper stars. Lily folded 40 stars in 5 minutes. Coco folded 42 stars in 6 minutes. If they work together, how many minutes do they need to make 300 paper stars? So again, like the previous problem, we have to find the rate of each person. So let's start off with Lily. Lily makes 40 stars in 5 minutes. So 40 stars divided by 5 minutes. Let's find her rate per minute. That would just be 8 stars a minute, right? Coco. This time it's 8. Folded 42 stars in 6 minutes, which means that 42 stars divided by minutes, 6, equals to 7 stars minute. Now we add these two together. 8 plus 7 equals to 15 stars a minute. Two people combined. So let's just make sure that we note this as two people combined, right? Because 8 stars a minute by Lily and 7 stars a minute by Coco. 8 plus 7, 15 stars a minute. Time to make 300 stars. 300 divided by 15, that would just give us 20 minutes, right? Because it's asking us how long will it take to make 300 paper stars. And if we divide it by 15 stars per minute, that would give us 20, which means that they have to use up 20 minutes in order to make up those 300 stars. Problem 5. A car goes to a town 120 kilometers away at 40 kilometers an hour and returns at 60 kilometers an hour. What is the total travel time? So let's say that the car just simply starts at his house, so home. And then let's say that this is the town, right? This is the town. Perfect. So it goes to a town 120 kilometers away, which means that the line here should be 120 kilometers. And the time to go would be 120 divided by 40 kilometers an hour, which means that in total it took 3 hours to get to town. And then on the way back this time, the car goes faster at 60 kilometers an hour, which means that the same distance, 120 kilometers, divided by 60 kilometers, this would take only 2 hours, right? Since 120 divided by 60 is 2 hours, which means that the total travel distance, 3 hours plus 2 hours, is equivalent to 5 hours round trip. And that's how long the car took to get to town. Problem 6. A delivery driver spent 6 hours on the road. She drove through city streets for 4 hours and on the highway for 2 hours. Her speed in the city was 45 kilometers an hour, which is half of her speed on the highway. How many kilometers did she drive in total during the 6 hours? So step 1, let's establish the city speed. The city speed, according to the problem, is 45 kilometers an hour. So, which means that the highway speed, since she drove on the highway for 2 hours, must be 45, which is the distance, times time, which is 2 hours, equals to 90 kilometers an hour. And this is her highway speed. And now let's find out the city distance. Again, it says that her speed in the city is 45 kilometers an hour times 4, since she spent 4 hours on the city streets. 180 kilometers is the city distance. And now we have to calculate the total distance, right? Because not only do we have to calculate the highway speed, city distance, but we also have to calculate the highway distance because we calculated the speed already, right? 45, again, 45 is going to be used a lot. So 45 times 2, since it's the round trip, half of her speed on the highway. So 45 times 2 would make up the full speed on the highway, which is 90, times 2, because again, she drove on the highway for 2 hours. 90 times 2, 180 kilometers, and this is the highway distance. So we have highway speed and highway distance. But this question is asking, how many kilometers did she drive in total during the 6 hours? Well, all we have to do is just add up 180 kilometers by 180 kilometers, right? We don't have to add up the 90 because that's simply the speed, not the distance, which means that in total she drove 360 kilometers in the time that she drove in the city. And that's how you do problem 6. Problem 7. A steamboat traveled downstream for 3 hours and covered a distance of 105 kilometers. It is known that the speed of the boat in still water, which means still water is not moving, the water is not moving, is 32 kilometers an hour, which means what is the speed of the water current? So downstream speed is equal to still water speed plus speed of the water current. Upstream speed, which is going up, equals still water speed minus speed of the water current. So let's first establish A and B. This is the two docks, right? Which means that this in total is 150 kilometers or 105 kilometers. And then the downstream time is going to be 3 hours towards the speed. 3 hours towards the speed. And then we are also given the formula, right? Downstream speed is equivalent to still water speed plus speed of the water current, while upstream is equal to still water speed minus speed of the water current. So wouldn't this just mean that the downstream is equal to the boat speed plus the current speed? This is going to be your formula for this question. And now we have to use the formula for speed, right? Speed is just distance over time, like we learned before, which means that if the distance is 105 kilometers and we divide it by 3 hours, this would just give us 35 kilometers an hour or the actual downstream speed. So this is the downstream speed. And now we have to use the downstream speed formula. Again, we repeat, downstream is equal to boat speed plus current speed. And since we know that the boat speed, as it's already stated, in still water is 32, so let's subtract 35 to 32, which gives us 3 kilometers, right? So what does the 3 kilometers represent? If we already found the boat speed, so we cross boat speed out, then that would just be the current speed or the water speed, which means that the water moves at a current speed of 3 kilometers an hour. And that will be your answer for problem number 7. Problem 8. Two docks A and B are 150 kilometers apart. A cargo boat departs from dock A and takes 3 hours to reach dock B downstream. On the return trip upstream, so again, we're going up, it takes 5 hours. It takes 5 hours to travel back from B to A. So this is going round trip. What is the speed of the boat in still water? So let's calculate distance from both docks. A, B. It's already established that it's 150 kilometers, right? No complications there. And then we have to figure out the downstream time. So downstream is just downstream is going to be 3 hours. And then the speed, we go to the speed, which is going to be 150, since 150 kilometers apart, divided by 3 hours, since it takes 3 hours to reach dock B, equals to 50 kilometers an hour. This is going to be your speed. And then the upstream, going up, is going to be 5 hours, since it says it takes 5 hours to travel back. Calculating the speed, this would be 150 divided by 5 equals to 30 kilometers an hour. So naturally going up is going to be much slower. And then now the equation that we're now given is simply just when we add up the total time downstream and upstream, this is going to be x plus y equals to 50, right? Because that is essentially calculating the downstream time. And then we have to do the same for the upstream time as well. So I'm just going to say that x is the water speed and y is going to be the current. Okay. And then when we go upstream, this is going to be x minus y because you're now going against the current, right? Which gives us 30. And if you solve this, you will see that, let's say x, let's look at this bottom equation. We add y, so x equals to y plus 30. And then we substitute x into this equation on top, so y plus 30 plus y equals to 50. And then we will note That's y plus 30 plus y equals 250. And then we can just say that y is equal to 10, right? And then now let's find out x, which is the water speed or the original equation. We can just plug it into this equation right here. 10 plus x equals 50, x equals 40. X equals 40, or the current water speed. What is the speed of the boat in still water? 40 kilometers an hour. Problem 9. On a dark and stormy night, Snoopy, the dog, suddenly saw a flash of lightning. 10 seconds later, he heard the sound of thunder. The speed of sound is 1,088 feet per second, and 1 mile is 5,280 feet. Estimate to the nearest half mile how far Snoopy was from the flash of lightning. So first we know that the time difference is 10 seconds. And basically, what this means is that from the time there is a flash of lightning to the sound of thunder took 10 seconds because there is a difference between the sound of thunder, which is typically slower than seeing a flash of lightning. So therefore, from the time Snoopy heard the flash of lightning to actually hearing the sound of thunder, it took 10 seconds. And it also says that the speed of sound is 1,088 feet per second and 1 mile is 5,280 feet. So if the speed of sound is 1,088 feet per second and it took 10 seconds to reach Snoopy's ears, then all we have to do is multiply 10 by 1,088, which would give us 10,880 feet. So that is the distance from Snoopy to the thunder. Okay, now that we figured this out, all we have to do is now just divide 10,880 by 5,280 feet. Why? Because we have to convert this to miles. And when we convert this to miles, you will see that although we don't get a perfect number, but it's still close when we convert it to miles. And this just gives us approximately 2 miles when we round it to the nearest half mile. 2 miles. And 2 miles is your answer for this problem. Problem 10. Emma rode her bike 30 kilometers to a lake at a speed of 15 kilometers an hour. On the way back, she rode at a slower speed of 10 kilometers an hour. What was her average speed for the entire trip? So let's say here that she rode her bike from home. And then the lake will just be, let's draw a lake. This is going to be lake. So to lake is going to be 30 kilometers at 15 kilometers, which means that if she rode her bike 30 kilometers to a lake at a speed of 15 kilometers, this took her in total 2 hours, right? Since 15 times 2 is going to be cover the whole distance. Okay. And then traveling back, she rode it slower at just 10 kilometers an hour, which means that if she had to cover the same distance of 30 kilometers, then that would have taken her 3 hours, right? 3 hours, since 30 divided by 10 is 3. So the total distance would be 30 times 2, which is 60 kilometers. And the total time taken would just be 2 plus 3 hours, 5 hours. Which means that when we divide 60 by 5, this would give us 12 kilometers an hour. Or in other words, the average speed of her entire trip to and back from the lake is 12 kilometers an hour. Problem 11. A train leaves the station at 8 a.m. at 70 kilometers an hour. Another train leaves the same station at 10 a.m. at 100 kilometers an hour. When will the second train catch up to the first train that left at 8 a.m.? So let's see here. Train 1 left 8 a.m., while train 2 left at 10 a.m. So the head start of train 1, head start, let's just say T1, is going to be 70 kilometers an hour times 2, since the difference between 10 a.m. and 8 a.m. is 2 hours. It had 2 hours. time to get a head start equal to 140 kilometers. So by the time train 2 departs, head start of train 1 is already 140 kilometers away. So the time to catch up now would have to divide 140 kilometers by the distance between the two train speeds. Why? Because in order to catch up to train 1, you would have to cover the distance that you've already lost, which is 140 kilometers. And since the distance or the distance in speed between 70 kilometers an hour of the first train versus 100 kilometers of the second train, then that would mean that the total distance in speed is 30 kilometers an hour. And using division, we can divide 140 kilometers by 30 kilometers an hour, which would give us around 4 hours, 40 minutes. Add 4 hours, 40 minutes to 10 a.m., which means that by the time second train catches up, it would have been add 4 hours, 40 minutes. This would give us 2:40 p.m. by the time train 2 catches up to train 1. Problem 12. Emma and Liam are working together to assemble 114 toy cars. Emma can assemble 5 toy cars per hour, while Liam can assemble 8 toy cars per hour. Emma starts working alone. 2 hours later, Liam joins her. They continue working together until all 114 toy cars are completed. How many total hours does it take to finish the 114 toy cars? So we know that the speed Emma works is 5 toy cars per hour, while the speed Liam works is 8 toy cars per hour. So when Emma works alone, Emma alone 2 hours, then wouldn't this just be 2 hours times the total number of cars that she made per hour, which means that she made 10 cars when she was working alone. Which means that the remaining cars that they have to make is going to be 104 cars. And then working together, now, we just add up their toy cars rate. So 8 plus 5 equals to 13 cars an hour. And all we have to do now is divide 104 by 13, right? So 104 divided by 13, this would give us 8 hours. So the total time, remember, we have to add the 2 hours that Emma worked alone as well, right? So 2 hours plus 8 hours that they work together is going to be 10 hours. So 10 hours is going to be your total time to complete 114 cars. Problem 13. Jason needs to drive 180 kilometers to a conference. He plans to arrive in 3 hours. For the first 1 hour, he drives at his planned speed of 60 kilometers an hour. Then he runs into traffic and can only drive at 30 kilometers an hour for the next 1 hour. And in order to arrive at his conference on time, how fast would he need to drive to cover up the remaining distance? So total distance is 180 kilometers. And we know that the total time is 3 hours. So the first hour, we know that he covered 60 kilometers. And then the second hour, he covered 30 kilometers, which means that the total so far that he traveled is going to be 90 kilometers. However, he still needs to make up 90 kilometers, right? Because the time used is 2 hours and he has only 1 hour left to get to the conference on time, which means that the time required would simply be 90 kilometers per hour, right? Since the distance he still has left is 90, and then he only has 1 hour left, which means that he literally has to drive at 90 kilometers an hour to make it to his work conference on time. Pretty easy since you don't really need to divide since you literally only have 1 hour. So just leave it like 90 kilometers. Problem 14. Two friends, Alex and Ben, left home at the same time to walk to a bookstore, which is 1,800 meters away. When Alex had 300 meters left to reach the bookstore, he realized he forgot his wallet and immediately turned back. He met Ben 400 meters away from the bookstore while returning. At that moment, both had been walking for 20 minutes. How many meters per minute does each person walk? So let's understand Alex's journey. Alex walks from home towards the bookstore, from home to store. The total is 1,800 meters away minus 300 because when Alex had 300 meters left to walk, which means that he walked 1,500 meters. And then he turns around and walks back from that spot until he meets Ben. And the meeting spot is 400 meters from the bookstore, so Alex walked from 300 meters away from the store to 400 meters away. That's the distance of 100 meters back. So total distance Alex walked is going to be 1,500 meters for to walk to the bookstore, plus 100 meters back since he walked 300 meters away from the store to 400 meters away, which means that in total he walked 1,600 meters. And he did this in 20 minutes, which means 1,600 divided by 20 equals to 80 meters a minute. And this is Alex's speed. So let's highlight this. And then let's also understand Ben's journey. Ben walked from home to the meeting point, which is 1,800 minus 400 since Alex walked 400 away from the bookstore, which means that Ben walked 1,800 minus 400 equals to 1,400 meters. And this one's easier, right? We divide it by the same 20 minutes since they both walked 20 minutes. 1,400 divided by 20, 70 meters per minute. And these are your final answers, 70 meters a minute for Ben and 80 meters a minute for Alex. Problem 15. A drone can fly at a speed of 45 kilometers an hour in still air. One day it flies from station A to station B with the wind and takes 3 hours. The wind speed on the outward flight is 5 kilometers an hour. On the return trip against the wind speed increases to 15 kilometers an hour. How many hours does it take the drone to fly back from station B to station A? Remember, we still have the same formula. Speed with wind equals to still air speed plus wind speed, while speed against the wind, which means you're pushing against air resistance, is going to be still air speed minus the wind speed. How do you approach this? Well, we are given, right, that the speed in still air is 45. Speed still air equals 45 kilometers an hour. And the outward wind is going to be 5 kilometers an hour, the outward wind. Outward wind is going to be 5 kilometers an hour, since the speed of the still air is already going to be 45, plus 5, since the wind speed on the outward flight is 5 kilometers an hour, is going to give you 50 kilometers an hour for the outward wind. And then finally, the time, right? In total, it takes from station A to B with the wind 3 hours. Times distance. And distance, as we already calculated previously, is going to be 50. So 50 times the time is 150 kilometers total distance traveled. And the return trip this time is going to be against air resistance, which means that the wind, as stated in the problem, is going to be 15 kilometers an hour. And this will lead you to the speed, which is going to be 45, which is speed in still air, minus 15, which is going to be 30 kilometers an hour of wind speed. And then the time, again, the time doesn't really change, except this time we're dividing 150 kilometers by 30, which gives you 5 hours total travel time on the return flight. Which means that how many hours does it take the drone to fly back? This would be 5 hours. 5 hours is your answer. Problem 16. A train that is 200 meters long passes a person standing on a platform in 15 seconds. It then takes 30 seconds to completely pass through a tunnel from the moment the front of the train enters the tunnel to the moment the tail finally leaves it. The question being asked is what is the length of the tunnel? Well, first, let's collect all the information that we're given. The train is 200 meters long, and it also says that it passes a person standing on a platform in 15 seconds. So let's draw a box to represent the train. Let's also draw a circle to represent the front of the train. And in 15 seconds, from the front of the train passes the person all the way to when the tail of the train finally passes the person. This in total takes 15 seconds. And it covers 200 meters, right? Because that's the length of the train itself. Similarly, it says that it takes 30 seconds to completely pass through a tunnel. Again, let's draw a line this time to represent a tunnel and then a sort of round shape to represent the tunnel. Again, the train starts its journey when its head enters the tunnel to when it finally leaves the tunnel via its tail. The entire journey takes 30 seconds to the moment the train enters, all the way to when it finally leaves. This in total takes 30 seconds. So what's the distance of this entire travel? Well, we know that 30 seconds is exactly 2 times as much as 15 seconds. So if the train takes 15 seconds to travel 200 meters, then it should take 400 meters to travel 30 seconds. And since we are counting the distance of the train, right, which is 200 meters, then all we have to do is subtract 200 from 400 to get the distance of the tunnel, which is 200 meters. And 200 meters is your answer. And that is how you do problem 16.